I'd like to describe our research regarding radial magnetic resonance fingerprinting for quantification of T1 in a preclinical breast tumor model. I have no financial interests or relationships to declare with regard to this work. I'd like to give an introduction to MR Fingerprinting, which uses a pseudo-random series of flip angles to produce what is seemingly a chaotic MR signal profile. If you perform this with undersampling, you can accelerate the analysis or the acquisition, and we prefer to use a radial undersampling method in this particular work. The seemingly chaotic MR signal is then fed to a database of profiles of signals that are theoretically calculated, and that then can be used to output property maps of T1, T2, and M0. So the first goal of our study was to develop an undersampled radial imaging MRF method for preclinical imaging. To apply that to estimate T1 times with outstanding accuracy and precision, and then to apply that to a preclinical model at 7T. Now, while MRF has been well developed for clinical imaging, clinical MRI scanners do have higher quality. Preclinical MRI scanners have lower quality due to variable B1 and B0 and homogeneity and some other issues. So performing preclinical MRF is a challenge, and this work is really addressing the challenge. So in terms of methods, we created phantoms doped with gadolinium. We also developed a 4T1 tumor model for the in vivo studies. We then performed MR fingerprinting using relatively standard MRF parameters with 8 times undersampling, and that allowed a total acquisition time of 7.5 minutes for both the phantoms and the tumor model. We also did a standard saturation recovery spin echo method, which was 19 minutes and 32 seconds, performed very carefully so that we can ensure that we have accurate and precise T1 times for this so-called gold standard method, to which we will compare with the MR. So the phantoms were embedded within an agarose container, so they have a fairly good B1 and B0 in homogeneity. We got outstanding maps showing the range of T1 relaxation times measured with MRF. And if we compare the MRF method to the standard gold standard saturation recovery method, well, we have outstanding precision with an outstanding R-squared value, and Lin's concordance correlation coefficient as a measure of accuracy. Also, measure is sensitive to precision, but we're really using it as a measure of accuracy. That's also outstanding. So then we performed the MRF method in vivo. Here's one example of an anatomical image localized with standard rare imaging. Then we do MRF to produce parametric maps of T1, T2, and M0, and then compare with the saturation recovery method. And we see that the average T1 from MR fingerprinting in this tumor is 1100 milliseconds with pretty good standard deviation that includes both the engineering and the biological deviation of those pixels in the tumor. So please keep in mind there's biological variation within the tumor. And that compares very well to the spin echo T1, which was a second, with higher variability, showing that the MRF, which has the same biological variability as the spin echo, well, it has a higher or better precision than the spin echo method. So in conclusion, we have created this MRF method. We have demonstrated that T1 can be measured accurately and precisely, and we have performed this with a preclinical model at 7T. So now the method is established, and now in the future, we can accelerate this method. We'd like to get down to 30 seconds to perform PCE-MRF, which can then be used to study the tumor vasculature in response to a vascular disrupting agent. And these future studies will then provide a clinical translational pathway so that we can implement DCE-MRF in the clinic to improve upon studies of vascular perfusion. Because DC-MRI is noisy and imprecise, MRF has a great potential to improve upon that precision. Finally, I'd like to thank our research group at MD Anderson, also our collaborators at Case Western Reserve University, who are co-authors of this work. And then finally, I'd especially like to thank Chetan Dakan, who is a postdoctoral fellow in our research group and is really championing this work, along with Gary Martinez, the last author and corresponding author of this work. Thank you.